Okay, this is the upcoming lab. We're going to start dealing with the ESP32 board, so the Heltec board. Um, and so this guy here, now we've used it as a just basically like an FTDI chip. So the same thing that you are doing in Wayne's class with the FTDI chip to have your serial to USB, that's what we did with one of these. And so kind of handy if you have need to talk to a serial port. If you have a Node MCU or you have one of these around and you don't have an FTDI unit around, you just put the processor in reset and then just use the USB to serial interface. The FTDI we've talked about quite a long time ago, and it's got really good drivers, and that's what made it really popular. There's Cypress CP2102s are generally in the ones that we come up with, like Node MCUs or something like that. So any of those can be used. We want to use it as a processor now. The difference, between this is the ESP32 is the successor to the ESP8266. There's still many ESP8266s around. You can see from this week's lab, it's really easy to get a sensor or something going and push some data out to the cloud. And so we can do all the things that we can do essentially with ESP8266, we can do with ESP32. They have a board that's called or is referred to as kind of a node MCU for ESP32. It's a little fatter and it doesn't give you as many breadboard pin options on the sides and things. The version of the ESP32 boards that I have got for you guys is the Heltec's version so there's an ESP32 inside, but in addition, they give you a little OLED screen on it. And more specifically, on the one that we're using, it also has a LoRa chip, and I'll talk about the LoRa chip. So it's got an ESP32, so that comes with Wi-Fi and Bluetooth. ESP8266 just had Wi-Fi. The ESP32 that we have is a dual-core processor. There are some that are trying to compete in price that have a single core, but it's just the 32-bit ESP32. But it gives you, again, the Bluetooth interface, and the LoRa version, the Heltec version, gives you also this LoRa unit. And it does so because it has a LoRa radio, a separate piece of silicone on the side that talks to it. And so this lab, we're actually going to use that LoRa chip. We'll talk more about what all of those kind of are coming up. So ESP32. So almost any example that you see for an ESP8266, you can find similar or the same example that just compiles over for the ESP32. In addition, you have some samples to send data to your phone, for instance. Pretend you're a heart rate monitor or something like that and get applications over to your phone. So it says install a board support package for Arduino like we did, and I had just updated the lab. It actually pointed to a place that last year was a good place to go off Espresso's website, but it's got currently, if you follow the link on Espresso, the version of the libraries is 0.0.5 or something. This one's 1.1.0. So they've actually left that link there, but it's being supported more in the ESP Arduino kind of interface more. And so I say install a board support package for Arduino like we did with the Node MCU. So anything that you want to go use, you want it in the Arduino interface, so you want access to some of the libraries that are there for it. I download a version of Arduino, the latest version of Arduino, the zip file always, and then you extract it somewhere. I have a DevTools directory, and then you rename that extracted one, Arduino-ESP32, Arduino-ESP8266, and before you open it, then you go into the directory and you make a portable directory, lowercase portable. And what that does is it sticks all of the libraries, all the development environment, everything that normally goes into your hidden logged in app data folder under Arduino 1.5, if it's still the same as it always was before, and it puts everything there. But if you put portable, it puts it in that portable directory. So I keep things isolated. And so that's why we don't go like a system-wide install, because they've been getting better at it, but you'd have everything in one big mess and you go, okay, which things work for ESP32 and 8266, and all of the different directories get kind of hard to follow, and you just isolate everything. So anyway, so we do that just like we did before. You make this portable directory, and then you search for ESP32 Arduino, and you're looking for something that says board manager. You want to be able to install the board manager. It's a JSON file, JavaScript object notation. It's just a text file that describes what boards and things are available. And so you do that by going into your file properties and adding that board, just like we did with the ESP8266, you do with the ESP32. And so when you have that, and then you go to boards manager, then it's going to, just like with the ESP8266, it's going to go and say, oh, there's some more places to find stuff, and it will show you the ESP32 boards. And so you install the ESP32 support. It will give you ESP32 for all the different boards. One of the boards that's there is the Heltec. You have Heltec version 2s, I hope. There is on your board, there is a little V2, okay? And so they changed a couple of things around. There's a couple of pins that are changed in locations, and they kind of doubled the memory on these ones. So it should be a V2. You can use V1s for most of the examples and all the rest, but I'm hoping everybody has a V2. The pinout, anytime you want to go pinouts, incidentally, you search for, in this case, I'd say Heltec LoRa V2 pin map or something like that. And then you should get one of those. Let's see, got the one. So for instance, there's a nice one there, Wi-Fi LoRa 32 VT pin diagram. So it's showing me where all the things are. Now, some of the things around, some of the pins around what's ground and 3.3 volts and things, these have kind of changed between version 1 and version 2. So you just need to go and look for that. A nice thing about the pinout diagram as well is I'm going to be able to see, for instance, what's being utilized. And so it's highlighting some of the spots. So where some of the red arrows are, it's saying, hey, those pins are there, but we're also hooked up to things on the board. And so, for instance, if I want to use my OLED, I better not be using any of the pins that say OLED, because all of a sudden your OLED's not going to work, or your device that you hook up might not work because of conflict between them. So it's got some interfaces going out to both the SX1276, which is the LoRa chip. It's got outputs to the OLED screen and that kind of thing as well. Okay, so once we have that done, if you go into your manager, your file manager, it's going to sorry, your board manager. You're going to select again the Heltec version 2, Heltec LoRa. There is a board that looks just like this. It has the OLED screen. It's from Heltec, but it does not have the LoRa chip. So you just want an OLED screen and you want Wi-Fi and Bluetooth capability, but you don't need the LoRa stuff. It's a cheaper chip, so you can buy that kind of thing. And so when all of that's installed and you selected your Heltec LoRa version 2 chip, then you go to the libraries and you search for Heltec ESP32. And if you do that, that's going to give you the 1.10. If you go just to the Heltec site, again, it's 0.0.5 or something, and it doesn't have all the ones. It specifically doesn't have the board that I'm interested in. Let me just go to, if I can go over to see if I have it on this machine. So yeah, I don't have that currently, but you'll see I have ESP8266, one for the ST, one for the Uno. There's a new version 2. We're sticking with the Arduino before version 2 libraries, like 1.16, I think is the current one that we're talking about going there. So we go and install the ESP32 dev boards library. Then when you go into file program and look at examples, you should see way down near the bottom specific examples for the Heltec board. It has the generic boards up top. It'll have ESP32, all the ESP32 boards, because you installed the board manager for the ESP32, and then it will show you the ones from the file manager, the Heltec. And if you go into Heltec boards, let me see if I can. If you go into the Heltec boards, so there's a bunch of examples for the ESP32 here, all examples for Wi-Fi, LoRa, ESP32. You have all these different boards. That was part of selecting the board for the generic ESP32. And then when I went and installed the libraries, it said Heltec ESP32 board custom libraries. So these up here generally work for all ESP32s. They don't have the LoRa things inside them. They have Bluetooth, they have Wi-Fi, all of this. But in addition, the Heltec ESP32 boards under LoRa, there's LoRa multiple communication, and that's the sample that we're going to use in the upcoming lab. And so it takes a little bit just getting to there. Fairly quick at doing that though. So the sample code, it says here, this example, it says this example provides a simple way to achieve one-to-multiple device communication. Each device sends data in a broadcast method. Make sure the devices work in the same band, then set the local and destination addresses as you want. Send messages at every half second and poll continuously. Now, there's a couple of things. When you go into Board Manager, there's a ton of options. Like when you go to Uno, it just basically says program. If you go and look at Board Manager, there's selections for what you can do for your flash system, all sorts of things. One of the things it says is band. And so you want to change it there. You also want to change it over here. Now, by default, there's a couple of different radios that are on there and antennas. And this even says Wi-Fi LoRa 868. And 868 is a European standard, and we are at 915 megahertz. It's close enough for the antennas that they put into it. We just need to be transmitting at 915, okay? And so on the board support manager, it says by default, it'll come up and it'll say 868. We want to be 915. By default, this one comes up and it says at 868, and we need to change it to 915. That's the North American LoRa frequencies that we are going to be running. Okay, and so one of the common things, if somebody forgets to do that, they're not transmitting on the same frequencies that we're going to be receiving information on. So you need to make sure that that is just set up. And it says, here's an example, 868 E6 915. Well, it was 868. So we want to make sure that we are at 915. In addition, this thing has some code that goes and sends to, they're making their own little network using LoRa. And so it has a send address and a receive address and a receive broadcast. And the receive broadcast is going to be FF. And so if you send out FF, this software looks at FF and says, if it's FF, take in the information. Think about it like we're doing with IP. They're kind of mimicking that with a single byte address. And then it's saying, if you have other than FF, you're supposed to listen to that and do whatever it says for a broadcast. If it's your address, then respond back with the transmission and print it out or do what have you. And then you also have your sender's address, and you need to work that out with somebody else. And so what we've got here is it says, modify the code so that your first name is on the top of the OLED. I don't specifically say how to do that. The OLED stuff is not in this example. But if you go to File, HealthTech Examples, there's some LoRa examples, and it puts some different words on the screen. And I want you to make sure, and it by default is installed in this one. All you have to do is look at the right commands. It's initialized to HealthTech. You just have to call in the HealthTech to be able to write on the screen, and it says modify your code so that your first name is on the top line of the OLED, and receive packets with display on a line below. Transmit message from XXX, where XXX is your first name. Every minute, send the transmit message. Demo your transmission and reception. Submit a screenshot of the serial output of your board, your OLED, and the receiving OLED screens to the week 12. So there are samples in the HealthTech for the OLED screen to work. This example here, by default, will go and transmit out to a certain address. You just need to work out amongst yourselves in the lab who's sending from where, what your send and receive addresses are, and then be able to put something on the OLED screen. Okay, so that's up for next week. On Monday, we'll start talking about what exactly is LoRa, all the different things, some of the other information on the ESP32, and the benefits of some of the things that we've got in there. I'll let everybody study math, and we'll leave it there.
Thanks, Bill. Thank you. Appreciate it.